Hi, good evening, everyone. My name is Alla. I'm a PhD student in computer science in Oxford. It's quite rainy right now there. And today we're going to talk about spatial computing and spatial interface for augmented reality. Only spatial interface, because we are on the next stage of basically on everything, on interaction. And in this case, space is really, really essential. So as humans, when we move around as individuals, we can't really perceive the whole complex system from the single point, like at the first glance. We need to look at the left, at the right, and see different particular features from different perspectives. And even if we are looking at one tiny picture, we're still doing a lot of movements with our eye fixations, meaning that to perceive something, you need to accomplish a lot of different steps. And as humans, we also have some sort of a convention. We have an ideas that we agreed upon, like we will name something like this, and this could be real, and this would be something unreal, because we need to somehow have a framework for our lives. But I have a question about how and why environment determines what we will see, or the individual itself determines what he will see. On this picture, for example, you can see the magical d'Orsay Museum in France, and you can easily imagine yourself wandering around. But what actually drives you? What you see, different paths, instructions, annotations, guides, or maybe your personal intentions, something that you planned before. So can this question possibly have an answer? Whether environment have an influence, or our personal ideas, or our personal beliefs. This is a really, really nice and magical 3D illusion on 2D paper. And if you can just think about it, you see 3D images on 2D plane. You truly, truly believe that this is the 3D thing. But it's not. It's just the magic trick that your mind does, because it's how it works. It's just lines and shades, but you see this 3D magic on the screen, which is not real, unfortunately. And I want to just for a second to think what kind of illusions we could have in real life, in augmented reality, in 3D. Would be like 4D illusions, or something else, something more deeper, something unimaginable. And this is something really like standard. Just quickly forget about everything that you know about user interfaces and think about what we had before. Just think about something like if we had never invented a computer, like never. You have no experience with screens, with mouses. What would you have? You would have your body, because we evolved biologically, and we have things that we all have. And in this case, when thinking about future computing, and today I heard a lot about human computing, personal computing, body computing. We need to think spatially and bodily, because we evolved equally. And before computing, we have the same that we have now. Before first computer, we had our bodies, and now we also have our bodies. But if adapting that to augmented reality and to spatial computing, we need to think about the space itself, because augmented reality is for space, is for interaction with the environment. And instead of, for example, the classical magical WIMP or post-WIMP user interfaces, we can have, for example, not windows, but volumes. Many companies are talking about screenless interaction, and still some of them have screens and windows. But how to avoid it? What actually are we using? We're not using screens in space, we're using volumes of information, different areas of interest, for example. We don't have any folders to hold our stuff in. Instead, we have instances of real physical objects that we're all familiar with, that we can easily represent in 3D. Or, for example, locators. Well, if you go outside, you can see different, I don't know, signs, turn left, or how to find this convention center. I've been using this a lot today, this morning. And we can have the same in physical environment. In augmented environments as well. And this comes to the point when we ask ourselves, so what are we actually using? What metaphors of interaction are we using? And I tend to believe that we are our metaphors, the way we live, the way we behave. Just, for example, think about the basic and classical, probably, models of words and linguistical things that we're using every day. Like future is in front of us and past is on the back. When we are happy, we are up, and if you're sad, we are down. So each culture, or maybe each individual, have some basic spatial metaphors and references that we can use in our everyday life and easily understand them. Just think about having more physical experience to that metaphors. This is an amazing picture. I found it in the art museum in Vienna recently, and this proves the point that many scientists, they found that our brain can understand only one input of information per time. In this case, one metaphor. You can really hardly try to understand what's in there. Like we have a picture, a painting, we have a picture of a painting, and on that painting we have many different paintings, sort of a screens, like augmented reality screens with different flowers. But it's really difficult for your eyes and for eye fixations to understand all of them together. You will jump back and forth from one corner to another one to understand them, but it's really about that we can perceive only one item at a time, only one concept and one idea of spatial interaction, because it comes from our perception. At Oxford Brookes, we worked with BMW, because in Oxford we have Mini Plant, a company producing Cooper's car. And one of the experiment was to build a system to train future BMW employees on how to assemble a car, which is quite a difficult task. And on the left, you can see the BMW training panel. It looks like a stand, like a desk, and on there we have different connectors, and I was trying to think, okay, how we can manage them, how I can basically create a scenario for augmented reality, how I can use the space of this training desk to make persons use their natural spaces, like they have something that they will never use on the left side because they're not using this side anymore in their life. And it's quite difficult because this is just some loosely connected fragments for me. I can't really understand what does it mean, like, or potentially no one in this room can't, because it's just some random numbers. But how can I share with my colleagues? And I wanted to use the space to prototype something for augmented reality. I wanted to use something that we had before, something that we do in our everyday life, to basically act the experience of interaction. And we conducted a workshop, a prototyping workshop, with my colleagues and friends, of how we can basically use our room to create environment. The main thing about this is not only that we can, for example, spot some patterns of interaction or some, for example, movements. We can use, in this case, our body. We can understand how we will move in the environment. We can use physical props. We can build real-size models. We can have many actors who will act the experience through the scene. And it was really nice to see participants explaining how the scenario would work using real objects, even though there were just papers and some quick style prototyping. But it worked really, really well, because they really understand what exactly they would build afterwards as a spatial computing. They explained that using their hands. They were trying to move quickly back and forth, how the interaction will happen. And I was really, really happy that they used their bodies to do that, because it is about spatial computing. And conducting that workshop helped me really well to understand some inputs that we use. For example, if you're from Finland, probably you would never use a lot of voice commands, because they're quite shy there. You would use some other inputs like gestures, because it's more natural for them, or for Italians as well. They're quite keen on using their hands as well. You can determine what types of interaction you will use using that conduction, using that spatial workshop technique, because it's really easy. Or, for example, my colleague William from Performance Augmentation Lab, he connected the Maya EMG wristband to the HoloLens to create a seamless interaction, because as you may know, with HoloLens you need to hold a hand in front of you, but with Maya now you can move back and forth easily, because you don't need to you're not locked anymore. It allows really free interaction. This is just the first prototype and demo where the HoloLens recognizes the Maya wristband, and you can move it and point it towards your target. In this case, it's William. But the whole thing that I'm doing and with my research is for training and for learning, because I think that in 21st century we need to use 21st century methods, but not some references from the past, which could be useful but not always. And with one project that we work on, Wearable Experience for Knowledge Intensive Training, WICIT, we conducted workshops with astronauts, with astronaut trainers in Italy, with aviation maintenance workers in Norway, and with ultrasound doctors in Italy as well. We're conducting the experiments to understand how we can train someone to complete the training in augmented reality. How can we capture the experience and transfer that experience to trainers? How does it work? How the spatial computing works in this case in industry trainings? For example, we were trying to use the area, I called it object-centered design, because in this case you can see the ultrasound machine and the bed with the patient lying on the bed. And we have the center ultrasound machine, and we're creating and highlighting a certain volumes on the ultrasound machine and creating a path, like we're recording a training for future doctors of what exactly the person will do in the future. Or another study that we conducted in Finland at VTT Research Center was about 2D and 3D interface, because there are a lot of talks about whether 3D or 2D would work in augmented reality. And we found that there are some different tasks that the person needs to perform. For example, if it is something for navigation, if you need to guide someone through the plant or through the room, you'd rather use 2D screens, 2D pointers for location and surfaces, because they're more familiar and understandable, easy to spot, easy to see. But if you want to show someone how to find an action, how to open the box in this case, because it was just a simple assembly procedure, you would use something more representative, 3D. For complex tasks, you're probably obliged to do that. But I also like about that experience the guiding lines. So you can see some parts of the orange lines, and there are your guidance points, directions of how you need to move and what you need to do. And probably the world is our canvas. Everything that you have and everything that you do in your life, it is the point where you need to create your interface. Spatial computing requires world thinking, managing your ideas in the everyday rooms and everyday lives. For example, you're sitting all in the room and you all know how to find the way from this room because you think in space. And I think that's what we need to use. We need to use our bodies and we need to use our environment. Thank you. Yeah, this is the website of our lab. You can easily find different news and works of my colleagues. Because we publish different works that we're doing with sensors, building a wearable solution with heart rate sensors, EMG sensors to record an experience, to provide a biofeedback. Personally, I'm working on human-computer interaction and trying to understand the spatial side of it. During this summer, we're going to conduct, again, trials with these 3 companies from aviation, medicine, and space sectors to prove the concept of this wearable prototype, and you can definitely find more on this website about this. Thank you again.